this is just an extension for chapter 10. Like we have different forms for linear equations, we actually have different forms for quadratic equations. And I wanted to take today to look at this form that's used more often in Algebra 2 so that you have kind of a preview of a different type of form. Vertex form is a form where the vertex is extremely visible. It pops right out at you, which is different from the standard form quadratic. We were just reviewing all of the equations, and then we decided to video this. So sorry you don't have that review. But we do, let's say again the standard form quadratic. Ready? Y equals
ax squared plus bx plus c.
So you do not see the vertex just popping out at you from that equation. You do see a point. What point do you see in that? Y-intercept, which is what letter? C. Good. So we have that. In order to find the vertex, you just told me that we would have to do what?
Over 2a.
Negative b over 2a, right? And that's only the x value of the vertex. You would have to plug that value back into this equation and find your y value. So it's kind of a pain. So we are looking now today at vertex form, which looks a little bit interesting, a little bit complicated. But the nice thing about this form is that when you have an equation in this form, hk is your vertex. So if someone gives you this form, you can see your vertex right away, which is the most important point we often talk about in a parabola. It's where the axis of symmetry is. So H is your axis of symmetry, right? And the A value is just like the A value in our standard form. It tells you whether the graph opens up or down. Okay, so one question might be, if you're given an equation in this form, can you graph it? So let's look at this. Everyone try to identify the vertex for this equation. And then come back and check. Okay, so the vertex, what do you think it is, Matt?
1, negative 1.
1, negative 1. Who agrees? Vertex 1, negative 1? About half the class agrees. It's not the vertex, so what's got to be changed? I mean, look at the form. The form is written here, and it's negative 8. So if we were to put this in that form, it's x minus what inside of here? X minus negative 1 squared minus 1. Now it's in vertex form. We're subtracting h. And what is h? Negative 1. So the vertex is negative 1, negative 1. Okay? That's the tricky part of this vertex form. It's not just addition inside of here. Inside of the parentheses, you're subtracting the h. When this number looks positive like this, then the h is actually negative. If it was minus 1 in here, then h would be 1. Okay, so that's tricky. So that's what you're going to practice a little bit today. Okay, the second thing we like to use, the second point we like to use in graphing is which point? Y-intercept. So, but we don't see the y-intercept here. You were not told that k is the y-intercept. K is not the y-intercept. K is part of this vertex, okay? So how could a person find the y-intercept? Ooh, good. Okay, I hear, there's like 3 ways I can think of, but I hear Tom saying you could plug in 0 for your x value, because as you look at the y-axis, a point on this axis would have an x coordinate of 0, right? You would walk nowhere and you would fly somewhere. So I really like that method of finding it. We would say the y-intercept is when x is 0, where is y, right? So you substitute. So if we go up to the equation, or let me bring the equation down here. We say y would equal 0 plus 1 squared minus 1. Right? Just plug it in, just like we did with exponential functions. Or we did this with linear functions, right? And what is 0 plus 1?
1.
And 1 squared?
1.
1 minus 1?
0.
0. So the y value in this case is 0. So this has a y-intercept at 0, 0, the point of origin. 1, 2, 3, 4, 5. Okay, so let's put that there. We have that. We also have the vertex at -1, -1. So could you find a third point right now? Somebody else, where can you find that third point? The same way we did throughout this chapter. Here's the vertex. Here's the y-intercept. Where's the other point?
The opposite.
Okay, so the vertex we know is on this imaginary, this axis of symmetry. And this y-intercept is one away from that axis. So here we go. One away from it on the other side, we have a third point. So with these 3 points, we can graph. There you go. We really only need 3 points, right, to graph a quadratic equation. One of them always being the vertex. So we know where that is. Good. There's a second way of finding the y-intercept, and that would be to take this equation and put it in what form? Put it into your standard form, where we know C is the y-intercept. So if we do that, look at, here's the equation, y equals x plus 1 squared minus 1. So who can tell me what x plus 1 squared is? X plus 1 squared. You all can tell me this. Y equals, what is x plus 1 squared? X squared, okay, Madeline, tell me, x squared plus 2x plus 1. That's what's inside of these parentheses, right? And we still have this minus 1 outside. So don't make that mistake of thinking that this is x squared plus 1. Remember that critical error that people make? If you take x plus 1, and multiply it to itself, you have x squared plus an x, so you've got 2x, right, plus 1. Not just x squared plus 1. Okay, so we have a positive 1 and negative 1. So look at our equation says y equals x squared plus 2x. I don't see a c, so what could we add?
0.
And isn't that what we said the y-intercept is, right? Now at this point, would you rather use method 1 or method 2? Who likes 1? Who likes 2? For this equation, I like 1, but you can use 2, it doesn't matter, I heard somebody else say, I just like the fastest method, and for this equation, I thought plugging in 0 was really fast, but either of them works. And I heard somebody say you could make a table and just graph it and look for the y-intercept, and that's true too. But we were trying to find points to graph. So that would just be graphing another way. You can always make a table to graph equations, right? Plug a point in, get its partner out, get the other coordinate of that point out. Okay? So the next question and the final task today, and the little practice you're going to do, is to write an equation in vertex form. This equation is in standard form. And how do we put it into this vertex form? When we look at vertex form, what do we call this part of it here? X minus h squared. What do we call that type of expression? It is the square of a binomial. And what expression do we get a square of a binomial from? Very good, Kate. Perfect square trinomial, right? So we want to take this entire equation and try to find a perfect square trinomial in it. And I don't see it right now because while the first term is x squared, this last term is not a perfect square, right? So there are a couple ways to do this, but here is one way. We want to rewrite the equation so that we can take these first two pieces, right, and find a c to add to it that will give us a perfect square trinomial. So what will we add? If we ignore the 15 and just push it to the right, what can we add? Or what do we need to add? 16, right. So when we add 16 to this, we now have here a perfect square trinomial, yay. But we added 16 to the right side, so what else do we have to do? Good, add it to the left. Okay, so now when we simplify this, we have y plus 16 equals, rather than writing it as a perfect square trinomial, let's write this as a square of a binomial, which is the factored form, right? So Jack, what is it? Good. So the square root of this, right, and the square root of this, and together those would create that middle of 8x, right? And don't forget we have 15 trailing along to the right. Now to finalize this, to get it into function form, we isolate y, right? So what do we do to isolate y? Subtract 16 from both sides. And we have y equals x plus 4 squared minus 1. So let's identify the vertex. We all do that? And let's say the vertex is?
Negative 4.
Good. Negative 4, negative 1. And the y-intercept. Who knows it? The y-intercept? Wait a minute. This doesn't give us the y-intercept. You got to look up here. And it is 15. Okay? Or you could call it 0, 15 if you wanted to give it as an ordered pair, right? So when you want the y-intercept, you do not look at vertex form, you look at standard form. But if you want the vertex, you look at vertex form. This may not be the best outline of how to change a standard form quadratic to a vertex, but at least it's a little start. Our goal was to create a perfect square trinomial, and then factor that to the square of a binomial and add k to that squared binomial. Okay, these are two that are on the little assignment. The little assignment is a way for you to explore this concept of vertex form, but this one says to graph it. So we're going to do a quick graph, and then the second one is put it into vertex form. So if you're asked to graph this, there are two things that we love having. The first is the vertex. So let's go find the vertex, and we can see it. This is vertex form. So Kyle, what's the vertex?
It's -2, -5.
Good job. Got it. Now the other is the y-intercept, and then we can find its reflection, across the axis, if only we could find it. So the y-intercept is not -5. Are you going to say that again?
Yes.
It's not, because it's not visible in this form. So how do you want to find the y-intercept? Somebody. How about we said if you plug in 0 for x, it will pop out, right? You walk nowhere and you fly somewhere. So look, this is so easy to do. Plug in 0 and you get 0 plus 2 squared minus 5. And what is 0 plus 2? Squared? Minus 5? There you go. That was not painful. You got it. So let's go graph. Is this opening up or down when you look at this term here, the A term? What is the A term? Not 0. I was making a space, not a number, sorry. That's a 1 out there. Okay, so there's an invisible coefficient of 1. It's positive. This is opening up. Okay? So we plot. Vertex at -2, -5. These are different colors. Okay, and then we have a y-intercept at 0, -1. So here is this axis, right? So there's that y-intercept. Where is the reflected point? Who can name it? Say it again, Aaliyah? -4, -1. There it is. So this point was 1, 2 away, right? So this point is 1, 2 away. Okay? And then I want to erase those. That makes no sense. And we graph. There you go. Using those 3 points. Well, actually, I'm doing a little bit more challenging changes to vertex form. I'm going to have to pause the video. You're going to have to just see the answer. There's not time. You'll have to pause and read this through.